Our father Newton
had a mission
to discover everything about forces,
who was stopped after his untimely death.
We vowed to complete his mission,
to continue what he couldn't finish. About forces.
Hello, beautiful.
Good evening, everyone. Today I'll be announcing my scientific discovery about forces.
I have a question. If you really did discover Newton's laws, then what is Newton's first law?
Another question?
What about the second law?
Do not ask this type of questions.
Why aren't you answering our question? What's the third law?
My dad discovered that force is any push or pull, and the unit for force is Newton, and force can speed up or slow down motion, or start or stop motion, and it can change direction.
There are two types of forces, contact force and field force. Contact force requires direct contact between both objects. For example, friction, push or pull, change direction. Field force acts at a distance, for example, static electricity, magnetic field, and lastly, gravity.
Okay, and there are two types of diagrams in forces. The first diagram, which shows all the forces in an interaction, and a free body diagram, which focuses on the object of interest and shows the forces acting on it.
And now the thing I discovered is Newton's first law. Newton's first law is when an object is at rest, it will remain at rest, and when an object is in motion, it will continue in motion with a constant velocity unless it's experiencing a net external force. And this law is also called the law of inertia, and inertia is the tendency to not accelerate. Now we have a question. A 10-kilogram box that's on the ground. Now we need to find the normal force. To get a better understanding of how to find the normal force, we need to draw first. Now, as you can see here, we have two forces acting on the box, normal force and gravitational force. First, to find the normal force, we will have to find the gravitational force. The gravitational force equals m times g, which is mass times 9.8, which will be 10 times 9.8, which is 98. And now to find the normal force, we will subtract normal force from gravitational force equals to 0. Then we'll substitute minus 98 Newton equals to 0. Now to solve this, we'll move this to the other side, which will make normal force 98 Newton. Now let's solve B. If you push the object down with a force of 20 Newton, what will the normal force be? Okay, so we have a new force acting on the box, which is pushing it down 20 Newton. So to find the new normal force, we will subtract normal force minus Fg minus the 20 Newton, which is the push force, equals to 0. So then we need to substitute, which is 98 minus 20 which is the push, equals to 0. Since we have here both negatives, we will add them, which will make them 118 minus 118 equals 0, and then we'll move it to the other side, which will make the normal force equals to 118 Newton.
Newton's second law. The acceleration of an object is directly proportional to the net force acting on the object and inversely proportional to the object's mass. So the equation is net force equals mass times acceleration. Our question says, Miriam is pushing a 10 kilogram box with 90 Newton force to the right. Find acceleration. So our given, it's mass equals to 10 kilogram and force, which is 90 Newton. Our unknown, it's the acceleration. So we're going to be checking the triangle. We have the acceleration as the unknown. That means we're going to be dividing force over mass. So our equation is going to be A equals to F over M. We're going to apply 90 over 10, which is 9. And we're going to be putting the unit for the acceleration, which is meter per second squared, to the right.
So I discovered something called the normal force. The normal force is a force that is exerted by the surface on the object. So if this is a surface and there's an object on top of it, the force is pushing up, and the forces always exist in pairs. So if I'm standing here, there's a force, I'm acting a force, and the floor is acting on me. So this leads to my law, which is the third law, which I discovered, which is for every action there is an equal and opposite reaction. So the last thing we will be talking about today that is relevant to solving equations is weight and mass.
Mass is the amount of matter in an object.
And weight is the amount of gravitational force on an object.
Weight depends on the acceleration of gravity. And the equation is weight equals mass times acceleration of gravity.
Mass is the same in different locations. So if you go to a different planet, the mass will be the same. But weight changes with different locations. So if you go to a different planet, the weight will be different.
And now we're going to be solving some problems.
Okay, so now we'll be solving this question. The acceleration due to gravity on the surface of Jupiter is 2.4 times that on Earth. If the weight of a rock on Jupiter is 70 Newton, find its weight on Earth. So first you will put the equation Fg equals mass times gravity, and you will be finding the mass because it is the same in all locations. So you'll put 70 is equal to the mass times gravity, which is 2.4 times that on Earth, which is 2.4 times 9.8. After doing that, you will multiply it, and you will get 23.52, and you will divide both sides, and the final answer will be 2.97 kilograms. And then you will find it on Earth, which is Fg times mass times gravity, which is 2.97 times 9.8, and the final answer is 29.1 Newton.
The question says the gravity on Mars is 1/3 that on Earth. Calculate the force of gravity on a 3 kilogram object on Mars. So we have as given mass, which is 3 kilogram, and gravity, we all know that it's 9.8. We're going to use the equation Fgm equals to mass times gravity. So 3 times 1/3 times 9.8. By using the calculator, you're going to get 9.8, and the unit is Newton.
Okay, I stopped. Security! Good morning, ladies and gentlemen. So, once I was detected attempting to steal their discoveries, I felt awful about what I have done. So I sent them an email a few days later, expressing my regret, which they accepted. After that, I began studying the Newton's laws in greater depth. And now, my recap for the 3 laws is as follows. In the first law, an object will not change its motion unless force acts on it. And in the second law, the force on an object is equal to its mass times its acceleration. And finally, the third law. When 2 objects interact, they apply forces to each other of equal magnitude and opposite direction. We ultimately started working as a team and began to perfect the formulas together, ensuring that all the formulas worked on every scenario. And recently, we have discovered how to calculate force at an angle. Okay, so after we worked together, we perfected how to find force at an angle. If you have force at an angle, you're gonna draw a square. For example, if you have box on the floor, okay, we're gonna draw now the Fn and the Fy. This is the Fn, which is the normal force, and down the Fy, which is the force of gravity or the weight. And the box is being pulled at an angle, which is the Fp. Now we have to draw an imaginary line on the x-axis and also across the y-axis. This is going to be called the Fpx, and this is the Fpy. And now to find the Fpx, the equation is Fpx is equals to Fp times cosine theta. And the Fpy is the same, but instead of cosine, we're going to put the sine. So it's going to be Fpy equals Fp times sine theta. Okay, so the question says Jenna is pulling a 10 kilogram box by a force of 90 Newton at 30 degrees with no friction. A. Calculate the acceleration, and B. Find the normal force. Okay, so this is the free body diagram. First, we're gonna draw the Fpx and also the Fpy. And now we're gonna calculate them. Let's calculate Fpx. Now, when we know the equation of the Fpx is that Fpx is equals to Fp times cosine theta. And now let's apply. Fpx is going to be equal to 90 cosine 30. Apply it in your calculator and it's going to give you Fpx is equal to 78 Newton. And now let's solve for Fpy. Fpy is equals to Fp times sine theta. And now apply. Fpy is equals to 90 sine 30. Apply it in your calculator. It's going to give you that Fpy is equal to 45 Newton. And now the first part of the question says that it needs the acceleration. And we know that the net force on the x-axis, which equals to mass times acceleration. And because there's no friction, the net force is in the x-axis, which is 78, equals to the mass, which is 10, times acceleration. Divide by 10, divide by 10, so the acceleration is equals to 78 divided by 10, which is 7.8 meter per second squared. And now let's solve for the gravitational force, which is the weight, so we can know the normal force. The equation for the gravitational force is that it's Fg equals gravity times mass, and the gravity is 9.8 times the mass, which is 10, and it's going to give us 98 Newton. Now let's solve for B, which needs the normal force. First, we know that the net gravitational force is equals to 0. So it's going to be Fn minus the gravitational force plus the force of the pulling on the y-axis, which is equals to 0. It's going to be Fn minus 98 plus 45 equals to 0. And now Fn minus 53 is equals to 0. Now take negative 53 to the other side, so Fn is going to be equals to 53 Newton.